third lecture of the use of geosynthetics in the low volume road as part of the 3-day executive development program on the new technology initiatives in rural roads and use of the marginal materials. It's quite difficult after lunch to engage this session and make alive the participant as well as for the teachers also. Sometimes it's difficult, but I'll try my level best to give you the what best I can give you on the topic of use of geosynthetics in the low volume roads. And once I finish my presentation, we'll take the question and answers at the end. This presentation is for the betterment of the voice and audio. Let me stop my video. I can have only audio, right? So for the entire presentation is planned in this way, starting from the what is the history of the geosynthetics with the introduction and the preamble, what is the purpose of it, what is the payments and what are the things. Then listing out the different types of geosynthetics, their functions, along with the major applications of geosynthetics. And now the IRC SP, Indian Road Congress has brought on a IRC guidelines, code of practice. We will see what are the guidelines on the geosynthetics, and followed by some of the work on the geosynthetics carried out at NIT Warangal, summary and the discussion. So, sir, before I begin, let me give you a brief idea overview. Just the present form of the geosynthetics, or the present form of the synthetics and engineering applications, as achieved because of the several ongoing as well as the several efforts that has put by the researchers and also esteemed practicing engineers like people in the field and the polymer technologies during the past several decades, and today we stand at a very good sound and technical knowledge in the area of the geosynthetic applications in the infrastructure development. So the development and use of the polymeric material in the form of the geosynthetics and fibers, now the people are calling it is a new revolution, the new class of construction material, and it is having new revolutionized in the infrastructure and also the environmental protections in the construction of the industry during the past 3 to 4 decades. Especially when coming, as I told you the very first day, my rural roads are the low-cost roads, where I'm trying for a cost-effective methodology, cost-effective technologies. So engineers are always, engineers like you, engineers like us, you are always continually faced with maintaining and developing in a rural or a pavement infrastructure with a limited financial resources, especially our rural roads. Because the traditional pavement design and construction practices require a high quality of the materials. High quality material means to fulfill our standards, we require high quality of the materials. And we are all witnessing, we are all seeing nowadays, now and then newspaper and those things. In many areas of the world, the quality materials are unavailable or short in the supply. So due to these constraints, engineers are often forced to seek the alternative designs using substandard materials or commercial construction materials, and also new or green, innovative, sustainable materials in the design of the various infrastructure in general, as well as the for our rural routes also. So one category of such commercial construction aids is the geosynthetics. So under the family name of geosynthetics include a large variety of products which composed of the polymers and which composed of the polymers, geotextiles, geomembranes things. These polymers are designed to enhance the geotechnical as well as the transportation projects. So we have a different functions that are to be used in the payments. As we go presentation wise, we'll be seeing what are the various applications of these things. So engineers have grown increasingly interested in the geosynthetics in the recent past. Not only the uses, the correct use, because geosynthetics often provide an efficient, cost-effective, not only the efficient, cost-effective, environmental friendly, and energy efficient solution to the several problems. And simultaneously, I can confidently say that significant advances have been made in the use of the geosynthetics today in civil engineering. Not only in the civil engineering means we have applications in the geotechnical engineering, we have applications in the transport engineering, we have applications in the hydraulic, we have applications in the environmental engineering, and etc. So if you dig out the history and see what exactly where it was started, so the first use of fabrics in reinforcing the roads, I think was attempted and was given by the somewhere in the US by the I was referring to the later South Carolina Highway Department somewhere in the 1926, followed by the first geotextile used in a dam construction in 1970. That to be a needle punched non-woven geotextile was used for the filtration purpose in the dam construction. There also geofoam was originally applied as a lightweight fill materials in Norway in 1972, and thereafter there is a first conference on the geosynthetics in 1977. Okay, so these are the developments which has been taken place over a period of time. So these geosynthetics materials will help us in reduce the construction time, save the consumption of the energy, and also save the natural materials. So IRC SP 59 2019 has recently brought out a code using this geosynthetics materials where they addressed about the two major applications. One is stabilization and reinforcing of the pavement layers. Another is separation and filtration and the subsurface and surface drainage aspects of the pavement layers. So this, even though we are telling this is a class of material which is added to the traditional list of the civil engineering materials, but truly speaking in India, this material is underutilized, especially on the low volume roads. I can confidently say that low volume roads. So it takes good people to do the good work. Takes the good people to do the good work. So with this background, with this introduction, let's move further. Preamble. Why do we need this? What is the necessity? We all learned at our undergraduate level. There are different types of the payment: flexible payment, resin payment, composite payment, etc., etc. Now let us limit our discussion to the flexible payment. You know that the payment is consists of the different cross sections, as are different layers, multi layers, starting from the subgrade to the subbase, base course, and wearing course. All that our intention, all our aim in the design and construction is pavement should provide a good riding quality, safe riding quality, and also so safe load carrying capacity without going in an excessive deformation, without excessive cracking or a premature failure of the pavements. That was our motto. Okay, so this is the cross section of the flexible pavement. This is a cross section of a rigid pavement, and you can see this is the kind of a typical failure. This is a rutting. This is a fatigue cracking. So nowadays we are talking about the performance of the road. The term is the performance. Performance in terms of what? Performance in terms of the rutting, performance in terms of the fatigue cracking. We know the rutting is a longitudinal depression caused because of due to the repeated application of the wheel load. On our rural roads, we are defining rut depth as a 50 millimeter as a terminal as a failure criteria as per the IRCSP 2002, whereas on the high volume road, we are defining it as a 20 millimeter as a failure criteria structurally. So our purpose is my pavement should take the traffic load imposed by the different trucks and safely should transfer to the underground layer so that it can perform better. That's what our motto, that's what our preamble, that's what the things. So you can ask me, sir, what is the problem? What is the problem with we are doing that with a natural materials? That's fine. But as I told you in the very first day in my lecture, mode specification with the low volume road, we are all the world is already facing a crunch of the natural materials. So if you use this geosynthetics material, there is every chance that we can reduce the congestion of these materials. We can reduce the thickness of the layers. Thereby you can save the materials. Not only that, geosynthetics material will help us in extending and enhancing the life of the pavements. So most of the engineers, they feel that whenever we interact with the field engineers, field engineers, they say, sir, geosynthetics, if I add in geosynthetics, it is going to give my CBRF from the 2 to 10, 2 to 5. This is not the correct understanding. If we use the geosynthetics, use the geotextile, whatever it may be, it is not going to increase your CBR. It is not going to increase any. It is going to increase. It is going to extend the life of the pavements. It's going to extend the life of the pavement is one of the benefit, and it is going to be sometimes it helps in reducing the thickness of the base and subbase layer, and thereby saving in the material, saving in the cost of the constructions. That can be that is the motto, that is a preamble in using of the geosynthetic materials. So what is the geosynthetics? Yes, sir, it's very good. You are saying that this is the benefits. That what is the geosynthetics? So geosynthetics, as is given by the American standard testing materials, the ASTM D4439. It says that it is a planar product which is manufactured from the polymeric material, and primarily it is used for the purpose of the soil, with the rock, with the earth, or any other geotechnical engineering related materials as an integral part of the man-made project, structure, or a system. So this is what a classical and the most suitable definition that has been given by the ASMD 4439. So I just summarized that material into the one similar. So geosynthetic is a generic term for all the synthetic materials used in a pavements or geotechnical applications. But under the family name of the geosynthetics, this is a family name. Under the umbrella of the geosynthetics, there are variety types of the materials. So geosynthetics are commercially available in numerous types in the market today, with the different products or different brand names or different descriptive numbers, code, or etc. 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 However, the commonly available geosynthetics that we come across, the material is, if you look at the classification under the umbrella of the geosynthetics, they are one-dimensional, two-dimensional, three-dimensional. If you look at the one-dimensional, whatever we are using, every day in houses, straps, cables, TV cables, current wires, and all those things. If you look at the two-dimensional, under the two-dimensional category, we have a geotextile, we have a geogrid, we have got a composite material, we have got a membrane materials. The classification membranes. And also under the three-dimensional, we have geomats, geocells, geonets, matrices, geospacer, and etc. For the payment point of view application, the mostly I will be concentrating on these two things. What are the geotextiles? What are the geogrids? So within the geogrid again, woven geogrid, non-woven geogrid, bonded, welded, there is a classifications. Okay, so you can knitted, woven geotextile, non-woven, again non-woven, thermally bonded, chemically bonded, needle bonded. This is the broad classification that we can see. So geotextile also is a planar permeable polymeric textile in the form of a flexible sheet. And the current geotextiles are classified in the different way, like a woven geotextiles and as well as the non-woven geotextiles. So woven geotextile means a textiles which is produced by interlacing, usually at a right angles or two or more ends. I'll show you the pictures. The different elements will be covered. So those geosynthetics, you can see this. This is the non-woven geotextile. This is the non-woven geotextile. This is the woven geotextiles. This is the knitted kind of a geotextile. This is a stitched kind of a geotextiles. So these yarns, you can see this is the yarns, or this is a woven, like a sheet, and this is a non-woven. It is simply a raw materials. And not only this, we have got in a geomembranes. These are also something similar to that one. So these are like sometimes the solid sheets, sometimes the porous sheets, some of the permeable sheets, some of the. So these are also geomembranes also been used. But when it comes to our pavement engineering, part, mostly geogrid. Geogrid is one of the materials. Geogrid used within a pavement system basically performs the two main functions. So I'll come a little bit later of those functions. So a geogrid is defined as a material which is connected a parallel sets of, you can say this is a A1. So we call this ribs. Within this they have a biaxial and triaxial. This is a bonded one, and this is a woven geogrid, and this is also another kind of a geonets. So if you see that figure A, extruded geogrids. So this is a uniaxial, this is a biaxial, and this is also a triaxial, three-dimensional triaxial geogrids. Whereas this is the bonded one. Bonded means the welded one, and this is also kind of a woven geotextiles. So one of the beauty of this material is that this geogrid is that since they are consisting of a connected parallel sets of tensile ribs with an aperture sufficient size to allow the through of the surrounding soils, stones, or any other geotechnical materials. So whatever the market that is available in the presently existing commercial geogrid products, which includes mostly extruded geogrids, the market and woven geogrids, as well as the welded geogrids, and also geogrid composites. So these materials are extensively used in a pavement constructions. Not only this, we are also using in a geocells. So when it comes to the geocells, I was just referring yesterday what is the work this. So this is the kind of geocells. You have seen the self-filled concrete pavement yesterday, and there you might have used the three-dimension of this. So the beauty of the self-filled concrete pavement is mostly dependent upon the size, shape, and the kind of a orientation of this geocells. So I was just referring, there is a very minimal amount of work that has been carried out on the failure mechanism and the successful mechanism of the 3D geocells in the payments. And these are all geocells apparently they are much more expensive than the geogrid materials. And geocells major area of implementation is the use in the soil stabilizations. So even the geocells have seen very successful application in the subgrade as well as subbase and in temporary roads. All roads in area with a very low bearing capacity, as mentioning by Professor Ramanamurthy in the morning, the expansive soils or block cotton soils are having a low stone soils, such as a swampy and sandy areas, and also in the railroad ballast stabilization, the geocells materials have been preferred. Then another kind of materials which is also coming up and which also we are now interested in is the coir based products. Basically from the coconut, that is a husk. This is the husk that has been taken. There's a coconut tree. So in India, as you said that roughly somebody says that about 12.59 million tons has been produced, coir fibers, and we are utilizing husk is only 36%. And whatever the geosynthetics that has been produced across the globe, I think India consumes about only less than 1.5% what is produced. So within this coir-based geotextiles, we have a woven coir mat, we have a non-woven coir mat. Okay, so this material also, but only issue is these are the biodegradable materials. So, but they also serve as a different functions in the pavement. At least this also help in extending the life of the pavement. We have made some studies at NIT Warangal. I'll show you as we go to the presentations what are this important and what is the finding of the use of the geotextiles. Now these geotextiles are abundantly available in the southern part of the country, Kerala especially. We have a coir board. So there a lot of studies has been done right now in India, and people are started using this in the rural roads also. So if you say that all this material, geogrid, coir composite, woven coir mat, non-woven coir mat, I was trying to rank them where they use it. So geogrid with a non-woven coir mat appropriate in the their function is a reinforcement, as appropriate a separation, or it is a good with a gravel subbase layer 1 and layer 3, gradation 3. Whereas the coir composite is appropriate in reinforcement, appropriate in separation, it is also suitable with the moram and gravel subbase layers. Woven coir mats, reinforcement, separation, non-woven coir mats also reinforcement and separation, and suitable for the separation in all the a combination of these materials. Now, what are the main functions of this? What are the main functions of this geosynthetics materials? Basically, if you look at the any kind of literature, any kind of things, mostly you'll find main functions of geosynthetics are this. One is the separation function, reinforcement, drainage, filtration, erosion, or moisture barrier and contaminant. Let us limit our presentation only to the mostly this part or certain to this part. It's not possible for it to cover every part of this, but we will discuss elaborately what are this separation, what are this reinforcement, what is the drainage. So I was looking, this is the application as of right now. Separation about the 42% across the world, reinforcement is 4%, silt fence, erosion control, canal lining, drainage purpose, and also the asphalt overlay. And if you come to the in India, I was looking, road consists of 44%, drainage is 16%, erosion is this much, other application is 20%. So this is the main functions of this materials. Now let's move further. Geosynthetics in the road construction. Where do you use these materials? Sir, we know that we have a classical cross section of the flexible pavement, which consists of the subgrade, subbase layer, base layer, as well as the surface layer. Of course, in the rural road, we don't have any binder course. We are straight away using a surface course. Now, our point of concern is my rural roads passes through the typical terrain, difficult narrow areas, to the alignment passes through, like sometimes because of the land acquisition, it is a snake dance, a lot of things, problematic area. Because now, as I always say that the God has not created all of us as the same wisdom, same height, color, weight. So universe also something like that. We don't have a what you call a typical soil that is available. Different soils, different geographic conditions. So our alignment of the road also running through the different terrains, different geographical area. So whenever we encounter, suppose we encounter a subgrade soil as a weak subgrade soil or poor subgrade soil, what does it mean, the weak subgrade soil? Weak subgrade soil means a soil which is having defined as morning, having in a CBR of 1%, having in a liquid limit greater than 60%, okay, and so on. So we are defining a poor subgrade. So in order to, if this is the poor subgrade soil comes, if you are not going to treat properly these materials, this is what a kind of experience that we can without the reinforcement and with the reinforcement. So this picture tells us a pavement is constructed without any reinforcement or any usage of the geosynthetics, and this pictures will tell you with the usage of the geogrid and geosynthetics material they made as a reinforcement compared to this pictures, there is an improvement in this. So this is our preamble. So not only that, not only in the subgrade, not only subgrade improvement, it can act as an interlayer. It can interlayer within the layer. Also, we can put the interface between the base and subbase and subgrade, as well also base and within the asphalt layer overlay thickness with the properly treated these materials. So we have different applications, geosynthetics. So this is what the witnessing that with reinforcement and without reinforcement, there things. And only that, we'll also see what happens without geosynthetics materials. If I have any pavement layers, it leads to the local shear failure. If the same material, this picture shows what are the roles of the geosynthetics. In the first case, it's causing a change of the failure of the mode. Whereas B, your B picture shows you, this picture shows you, if you're applying any geosynthetic materials, they were trying to help in the form of redistribution of the stresses, the loads, and also making their confinement effect. And if you look at this part, C part, this also providing a vertical support that is called a membrane effect. So this is one of the research study which is in 1982, and finally D is providing a passive resistance to the interlocking of the soil particle. There is an interlocking effects. So this many benefits are there, and this is the basic things that the geosynthetics is used. Now, when it comes to the separation process, let us discuss one by one. What is this separation? Why it is required? Why it is required in a separation of the separation function? How it is important? So separation means we know that the concept of separation, perhaps illustrated by this figure. This figure, you can see this figures. So in a flexible pavement, if this is my subgrade, which is having a less than 2% CBR, can I place my subbase layer directly over the subgrade? The first question. Or the traditional construction is, normally we used to construct a base and subbase layer in a different layers. As yesterday somebody was asking, Salim engineers was asking the rural road, sir, what is the functions of this providing an upper subbase and lower subbase? So Normally in the rural roads also we are facing a crunch of the materials, because base course is the one superior one. We may not get the different, we may not get the superior quality of the materials. So what we are doing, we are trying to achieve the solid layer with providing two different materials. So there they are mentioning, if you are using the lower base course, it must satisfy the 50% CBR, and upper sub base it must satisfy the 80% CBR. Now here also we can try using it in a separation function, but the separation function is something different. What it does is it will try to give a function in such a way that it will segregate this layer and this layer. The intermixing of these two materials will not happen. If the intermixing of the two material will happen, then there is whatever you and me all studied in our UG. Flexible pavement is a structure. The load distribution will happen from the grain to grain distribution, or stone to stone contact. What happens is, this is what the kind of situation that will get it. So it is very recommended that geosynthetic separator is a placement of the flexible pavement, the porous textile between the dissimilar materials. So when you are placing a geosynthetics material between the two dissimilar materials, what we are expecting is that the integrity of a functioning of both the materials can remain intact, or the performance can be improved. In other words, let me ask you one question. Very simply, to illustrate the separation functions. Let us assume that. Let us imagine that a 10 kg of stone mass is placed in the 10 kg of mud. Now listen very carefully. What I'm trying to say in the separation function is, the 10 kg of stone mass is placed in the 10 kg of mud. So what is the net result? What is the net result? Any answers?
Sinking.
Somebody said Nagarjuna 20 kg. What is the 20 kg? You're right.
It will sink.
20 kg of mud. It results into the 20 kg of mud. So keeping this in mind, geotextile serving as a separation functions it successfully. So when placing a stone aggregate on a fine grained soils, you are placing in a stone aggregates on a fine grained soils, there you can expect the two simultaneous mechanisms that tend to occur over a time. So what are those two simultaneous mechanisms? One is that the fine soils will attempt or will try to enter into the voids of the stone aggregate. It will try to intermix the voids of the aggregates. Thereby, it's ruining it is spoiling, or it is ruining its drainage capability. That's the one function. The other mechanism is the stone aggregates. The stone aggregate attempts to introduce into the fine soil. Thereby, the stone aggregates, we will be losing the strength of the stone aggregates. So when this occurs, we have a situation called a sacrificial aggregates. This is called a sacrificial aggregate, which is all too often the case without the use of the proper separating geotextiles. This is what is shown in this mechanism. So that's, you can see here, subgrade, the intermixing, how in the fine grained soil is placed, how they are intermixing here. When they're laid with a separator functions, you can see how the geotextile separator function is performing. Okay, so you can see clearly here now the separation has also a compaction problem. So when I have a weak soil and I'm trying to put an aggregate over it, as I said, the two simultaneous approaches, as the soil attempts to enter into the voids of the stone aggregate here, as a result, it's reuniting, it is a drainage capability. So if you can try to provide some kind of a geotextile, a geosynthetics material here, we have provided here, this is a biaxial geogrid. Now you can see how the load distribution that is happening. So what this does is basically, it prevents the fine grained soils from the lowering the strength of the load bearing aggregate as the base course layers. And also proper compaction is also possible. So that's what one of the main thing that we use as a geosynthetics or geotextile is a separation functions. Other important functions are there as called as reinforcement. So reinforcement is very simple. If you I will tell you the very simple language. If you try to take any leaf, any big leaf, and at the back side of the leaf, you have got a reinforcement. And if you try to remove those, let's say take a tree called a badam tree, and take out his knots, the reinforcement at the back, and see how stable the leaf was. You can experience that one. If you remove the staple, if you remove the reinforcement, how it is going to be closed form. If the reinforcement is there, how stiff it is. So what I wanted to say here is a reinforcement means it is a synergetic improvement of the total pavement system, and which is strengthened, created by introducing a geosynthetics in the form of a geogrid, and which is good in tension, and also a soil is good in compression. So if you look at this figure, this figure, and if you look at this figure, three fundamental reinforced mechanisms have been identified, has been shown, involving the geogrid. So the first one is the lateral restraint. You can see this lateral restraint due to the friction. The second kind of things is the improved bearing capacity. And the third one, this is improved bearing capacity. The third one is the tension membrane effect. This is the membrane tension effect. So most aggregates used in pavement systems are, that is a stress dependent material, which requires improved lateral confinement and results in the increase in the modulus of the base course materials. So what you have to understand here is the effect of increasing the modulus of base course or sub-base course is an improvement in the vertical stress distribution applied to the subgrade, and the ultimate aim is reducing the corresponding reduction in the corresponding of the vertical stress or strain on the top of the subgrade. We know there are two important design criteria that we consider. So in this things, the main thing is this. As I said, all the pavement materials are stress dependent. So we have to keep the minimal stress or strain on the top of the subgrade. So this figure you can see this figure, lateral restrainment. This explains. And the second mechanism, improve the bearing capacity, is achieved by the shifting the failure overlap. The failure plane of the overlap also is a failure of the overlap. And the third fundamental reinforced mechanism has been termed as a tensioned membrane effect. A tension membrane effect means it is based upon the concept of something like a improvement in the vertical stress distribution. So improvement in vertical stress distribution means ultimately the stresses are strained that has deformation coming and the subgrade, it must be minimized. If that is minimized, that's what your pavement is going to perform better without any rutting, without any cracking, without any excessive premature failures. Okay, so this is what the fundamental separation as well as the reinforcement functions are going to. So you can see, is this problem is a civil engineering problem, or is this problem is a pavement engineer problem, or is this problem is a automobile engineering problem? You cannot say that I construct a road so your vehicle is wrong. It's not an automobile engineer problem. Definitely, it is a civil engineering issue only. So we need to address this issue. So by reinforcement, we can for this kind of a situation, the solution could be as I explained. The solution could be this: we have a weak soil, we have a reinforcement, and you can see now how the more effective loading distributions, and the ultimate end of the day, more the load distribution, wider the distribution, our subgrade is safe. We are trying to keep the subgrade in a safer conditions, as that other layers also keep in a. So providing a high strength at a low strain, resulting in a reduced aggregate thickness and the vertical deformations. This is what the scenario you can see. You can expect this kind of solution in the field. So I just made you for your easy understanding purposes, and thus just look at construction without the geograde reinforcement. Construction without the geograde reinforcement happens. This is my soil. These are the different layers. So you can see the effect is in the entire pavement section, including the subgrade. And the further movement, it goes inside and goes inside. That's why we have to reduce on the subsoil pressure. Load on the subsoil means we have to make use of some kind of an arrangement of the sensor geograde and the aggregate base and alpha asphalt, or it's all depend upon the auto design. This all depend upon your design requirement, your site requirement, your field condition requirements. So construction with geograde. Earlier case was this, and this was now the construction with the geograde reinforcement. Now you can see how steeply your pavement is load distribution. You have a granular base course, granular sub-base course, separated by the geograde of this layer, geogrids. This is a weak soil. Now you can see the effect. So making this kind of arrangements, making this kind of a construction, what it results, how we are going to benefit. Our ultimate job is that, ultimate aim is that we are going to reduce the sigma V and epsilon V. Sigma V is nothing but your horizontal tensile strain on the top, or stress or strain on the top of the subgrade, as well as the vertical compression stress or strain on the top of the subgrade, and also sometimes the bituminous layer. Of course, in a rural roads, we are using in the top course is a 20 millimeter. There is a OGPC, that's the open graded premix carpet. So we have got a different issue with these things, and we are not considering this layer as a structural layer. It is just in a dust palliative layer, which need to be provided with a good riding quality. So we will discuss more on this in the tomorrow at the last hour about the surface dressing when we discuss. So here, this is what the direct benefit you are going to achieve. The reinforcement is provided. Okay, and as a base reinforcement, benefit shows for a subgrade up to 8% CBR. Geograde primary is the reinforcement. Geograde separation also can be used, but they also again depend upon your aperture opening size and those things, but mostly in the reinforcement part. Geograde reinforcement is a function of lateral confinement, and the base reinforcement is also stiff materials, and also you should allow the geotextiles or geograde. They allow the aggregate thickness in directions, and also other benefits is geogrades as a construction expedient, base aggregate to the full depth prior to the spreading, and effective solution for the temporary construction purposes. So you can see here If at all you want to access from this side to this side, I have in a water logging boring area, small these things. You can see the people are they use some kind of granular materials. They're trying to put the geograde. This can help us in movement of the people. So very quick and easy access to the site instantaneously in the areas where a temporary roads arrangement has been done. And sometime when we make it during construction time, some of the soil, some of the ground, they may not, they are not in a position to support the construction equipments. There we can use this and try to see the improvement, and you can easily access to the sites wherever you want these things. And other important parameter, as I said, functions, as I said, is drainage as well as the filtration. This material is also used in a drainage, is also used in a filtration purpose. Fortunately, unfortunately, what I feel is sometimes that if at all given a is heavily dependent upon the drainage and also the filtration. So you can see this is the subgrade, and this is also subgrade, how the drainage and filtration criteria that they acts. So this is the containment. At a morning was Dr. Vishnu was mentioning about the pumping. Pumping is nothing but I call it a mud pumping. Mud pumping is the kind of a distress which exists mostly in the CC payments, and the success of the CC payment, any CC payment, is heavily dependent upon the your joint constructions, joint deterioration. If the joints are not properly treated, not properly constructed, and definitely you can see what happens. So this is the one slab, this is the two slab, the second slab, this is the joint. So because of due to the movement of the traffic, before the movement of the traffic over a period of time, the joints get deteriorated. Thereafter, by there is an elevation difference. So because of the elevation difference, it comes like this, and it also comes something like this. So this is the source of the water. When the water goes inside, whatever the fine particles that are present in the subbase cores, they ejects out, they comes out. So as the fine particles they started coming out under the dynamic traffic loading, as a repeated loading, slowly it gets damaged. So there also we can use as a containment, as a pumping in the hot mix asphalt as well as the base cores. We can use these materials. So this is what the a broad idea why how the geosynthetics use, what is important, what are the functions of these things. Now, recently, as I told you, IRC 59 2019. There is a record on the usage of the geosynthetics in the payments. I'll share with you the code of practice. You can go through these things. So these are all there they are given. What should be the properties? What are the test methods? What are the various acceptable quality control? All those things. This is the self-explanatory. But what they have mentioned, one of the things is that the typical value and the minimum average roll value. The term typical value, minimum average roll value, they both related to this both value are related to the what do you call it, variability in a geosynthetic material properties. So this variability originate from the manufacturing process and is also similar to that which occur with all the construction materials and etc. Because is 97.5%. 97.75%. That was been given. The minimum average value, it should possess us. So the typical value refers to the average or mean value and is valid on a geosynthetic materials. So when we test this, 50% of the test results can be expected to exceed this value. What is 97.1, and the 50% can be expected fall below this value. That's what the, so this MEARV is derived statistically as average value minus 2 times of the standard deviation on those things. But usually, whenever the geosynthetics provided, the manufacturer is going to provide all the kind of information. The information on the physical properties, mechanical properties, as well as the hydraulic properties of these things. So the physical properties includes your specific gravity, mass per unit area, what is the thickness of those, tensile strength, puncture strength, and all those. And as also I was talking, hydraulic properties, aperture opening size, geotextiles, permittivity. So for all these things, there are very good established code of practices given in ASTM as well as IRCSP 59 borrowed from the ASTM. One can see those requirement as we get the material to the site, and we can confirm those things. So these are all the geotextile properties and test methods, which is not necessary for you, but just for information. So physical properties, mechanical, hydraulic, this is a mass per unit area, and these are the code of practices that has been given. So you can always refer to those things. So when it comes to the physical properties, I said one is the specific gravity. So for the different fabric materials, polypropylene, polyester, nylon, polyethylene, they are given a range of the specific gravity value as well as the mass per unit areas, and the geotextile thickness ranges from the 0.25 to the 7.5 mm. And these are all the mechanical properties. Must be one has to see that about the what is the grab strength, puncture strength, and the sieve strength. So these are all the like our CBR, UCS, what are the related mechanical properties of the strength, which are tested according to this code of practices, and we can always see these materials whether they are within the limits or not. What is their effect on those? Then I was referring to the one of the very important thing is the Geosynthetics applicability assessment for the aggregate surface to pavements. This is an FHWA, a document where they are given a different cases. The cases is, case 1 is, assume that a subgrade CBR is less than 0.5. What is to be done? If the CBR is less than 0.5, the morning, as Ramana Murthy was mentioning in this first lecture, you adapt a mechanical subgrade stabilization. So in addition to adapting the mechanical stabilization, where we are trying to improve the PI properties, they recommend that based upon the wide variety of research, put a non-woven geotextile is recommended for a separation purpose there. Biaxial geograde is recommended for aggregate reinforcement. Aggregate fill should be used and no reduction in the aggregate thickness. Even though I said that earlier, geosynthetics material performing promisingly better when the subgrade CBR is 8%, and they try to give us a reduction in the thickness of the base course layers. In this case, the aggregate fill should be used and no reduction in aggregate thickness. Non-woven geotextile placed directly on the subgrade, geograde aggregate and fill the materials. This is the case 1. Case 2 is subgrade CBR is 0.5 and less than 2. Stabilization of base reinforcement. A non-woven geotextile is recommended for the separation of the subgrade CBR less than 2% CBR. And here, aggregate thickness can be reduced. Use a bearing capacity factor. Sir, tomorrow we have in the morning session one more lecture on the geosynthetics that is purely on the design methodologies. Today, I'm just giving what are the uses of geosynthetics, what is the function of geosynthetics, what test methods, what are the various uses, where can we use this. Actual design using this concept, we will discuss tomorrow. When we are discussing tomorrow, I will tell you what are these bearing factors, how they are developed it. And case 3, so and so, case 4 and so and so. Here you can see bearing capacity factor including both geotextiles and good geogrid. Now separation fine grained subgrade within a CBR less than 4%, and a CBR 2 and 4, the primary geogrid function is a base reinforcement. So this guideline we also can be used and try to implement, try to see in the field what happens. Fortunately, unfortunately, now after the 2000 to 2022, we are talking the new technology and those things. There is a lot. There is a lot of more way to go in the area of the geosynthetics, the geotextiles. See, unless until it is the you people, unless until who constructs the test sections and try to see how is the performance related to the control sections, we can also definitely benefits of. The strength of this material using a simple equipment called a dynamic cone pentometer, and you are trying to see within the sections as what is the reinforced section, what is the unreinforced section. You can see the difference. So this is the unreinforced section, this is the unreinforced section. See the rutting in the left wheel path and right wheel part of the sections. So Indian Road Congress has given a step-by-step procedure for the construction of the trenches, drainage lines, and all those things, which I'm not going to discuss things, but they say that. So this is the step-by-step procedure. It is self-explanatory. You can go through at any point of time and try to read these things. This is the process. First one is conventional pipe under drain with the geotextiles around the stone, and the geotextile wrapped one, geotextile wrapped stone in pipe in the trapezoidal section. So for this, we have a sequence of the activities, sequence of the works: excavate the trench, place the fabric, add the bedding materials, place or compact it, wrap the geotextiles, finally fill and compact it. So this is the procedure which is given. You can go through the material which I'm going to supply to, and also guidelines for also separation, reinforcement for the base, subgrade, and reinforcement function also is given. So clear any unsuitable materials, and if the CBR is greater than 1, lightweight profiling operation should be considered to locate the unsuitable materials, and all the weak parts, isolated parts should be removed. Care should be taken in the disturbance of the subgrade. Once the subgrade is prepared, try to use the geosynthetics based upon the design requirements and based upon your site conditions. So this is what the sequence of the activity: prepare the ground, whatever the geotextiles are recommended by the designer, bring the designer, roll it on the section. On this, we have a dumper, bring the aggregates, try to compact, spread and compact it, and this is what the final say, the compaction. So in this process, what if there are any excess defects, what kind of geotextiles, you are given a step-by-step procedure. You can just go through and read this matter. And one of the important things when making let us say I'm using materials, how the overlapping means. If you have a single 3-point lane, if I have strap this one, the next step I'm making, this is the overlapping. This is called an anchorage. So the code has given that overlap requirement geotextile for different CBR values. Soil strength is greater than 3, 2 to 3, 1 to 2, less than 1 are all road vents. Overlap is minimum this value, overlap is this minimum this value for different geotextiles. So you can just follow these guidelines, and accordingly you can, because the overlap is also very important criteria in achieving a good performance of the pavement. So most of all we come across the soft ground, this kind of a nature, very soft ground. So what I'm trying to do, I'm trying to create a way. Okay, so I'm putting a geogrid walkways, I'm creating a geotextile placement, bringing the aggregates, dump the aggregates, compaction traffic is allowed, and you see the alternate filling. This is what at the end of the day, your road could be like this. So this is the sequence, the subgrade separation and reinforcement functions, you can see. And not only that, this material also can be used in the erosion control as well as in netting and turfing. You can see on the banks of the natural water stream, erosion. Here also you can see vegetation, very nice vegetation, and the netting and also turfing also can be given. The slope stabilizations, especially the embankment. Mostly we can see in the coal mining area where they're dumping the excavated material in heaves, and they make the agitations. There also can be, this material can be used. And mostly my rural roads, my low volume roads is a very unique and insight in the rural areas where I don't have any to cross the major bridges or cross journeys. Wherever you want to make a temporary halt, you can see the geogrid is placed under the water and place the aggregates, and you can see here, you can feel up this water is there, how the mat is visible. So this will help us to move the traffics. So this book also I'll share with you. The low water crossing geomorphology, the engineering is given by the US Forest Department. So mostly this is the guidelines. So they are doing these things, and we know thus the application also one this fencing application also being given. Now when you make the as I said, the asphalt overlay or a heavily damaged pavement or heavily rehabilitation works required. So we can also use with the sealing of this kind of a crack, not the major structural crack, but you can seal with this kind of a crack. This is a fatigue cracking and rutting. Too much. No, the fatigue is there. Rutting is going to happen. So what we have to do is we are going to mill this pavement section. So in this case, the rutted section, they remove the rutted section, fatigue section, and repair the subgrade and subgrades. In doing so, you can patch repair section also. You can use this kind of materials, and this is what the band-aid interlayer or a PCC or a reflective cracking because this is an old pavement, you can see. Because of the old pavement it always try to know how the reflection cracks that comes on the top of the surface. To prevent this reflection cracking, this material also can be used in this form. Seat interlayer material within a modern equipment, and you apply the tack coat over it. The uniform, how uniformly spreading is there, you can witness here. And use also automated equipment to place fabric if possible. So you can see we are still in India, we are using the manual labor, but there is a market, automatic equipments are available to stretch and make these equipments. Then laying the coats, ensure the proper tensioning, and ensure that it should not wrinkle too much. The fabric should not be wrinkled. Okay, and then make the this is a manual fabric in curves, because in curve sections, wherever there's a curve sections like this, there's no sometimes difficult to place this. So use this kind of a simple manual methods to avoid the wrinkling of the any geotextile materials. So fabric, this is also a new role in the starting the overlapping to the, see this is the one end is over, they are making the new one, so that making the overlap and start the new role. So this is what a section where they are the new rule. So this is the sequence of the paved surface, and the finished product is this. And these are all the other kind of works in the laboratory. You can see this the laboratory works. Connected section of unreinforced sections. Okay. And finally, this is our subgrade. I'm placing a geotextile over it, making an aggregate placement, and avoid here when you're putting, as I said, you should avoid the thin lifts. Should not be a 5 mm, 10 mm, other things. Should avoid the thin lifts. And spreading the aggregate from the center to the shoulder part, dumping the aggregates, spread it with a mortar grader, whatever the things. Now you are finally the established final grade within a grader, ready for the compaction. This is what the sequence of the activity that we do. Now we have done it at NIT Warangal. What we have done it last year, before the last year, one of my student, a PhD student, what he have done is he has taken the different materials, woven coir mat, non-woven coir mat, coir composite, geogrid plus non-woven coir mat within a morum soil and as well as a BC soil. And he has fabricated a mold like this, 300 by 300 by 200 and 300 by 200. And this is the equipment which is called a wheel tracking. Which is the equipment called a wheel tracking attached to the computer system, and it will be moving backward, forward, backward, forward. So you can see here, this is the typical results. We are trying to establish what is the rutting potential of this and what is the number of wheel passes. So you can see here, this is the rut depth number of wheel passes at the h by 2 position. This is the h by 3 position in the mold. And this is, you can see here, 0, 5,000, 10,000, 15,000, 20,000, 25,000 and 30,000. For a 30,000 wheel passes, the repetitions, the unreinforced section without any reinforcement of morum soil, which is showing a rutting of 30 millimeter. And you can also see the same thing with the woven coir mat, non-woven coir mat. For the same application of the wheel passes, reinforcement with the geogrid plus non-woven coir mat could yield in a 5 mm rut depth. So there is a huge enhancement in the life of the pavement. So this is the laboratory study. So you can see this is what he has done. So this is the without reinforcement of a different soil, morum soil with a different PIs and black cotton soil, and this is the with reinforcement. And you can see you can feel the witness here even after the passing of h by 4, h by 3, h by 2. And this is also this is for the black cotton soil, and this is for the morum soil, and this is the laboratory. Now, very important aspect of it is, which India is lacking today, and we are also, sir, as of now, we are all talking about the new material, new technology, marginal material, sustainable material, green material, you name anything. But the success of this material heavily depend upon the usage and what are the outcomes. So if at all I wanted to test a X technology, some X technology, I contact you. We will construct a road today using some X technology. I have to wait 10 to 15 years. How this technology is performing, how the rut depths are there, or what is the performance of these payments, which is quite not recommended. In place of that, what we can do is we can make use of the APTF. That is accelerated pavement testing facility, or in other words, we call it a test track studies. So, even though we have carried out a study at the laboratory, it is always, all of us know that it is very, very difficult, and it's not that 100% I can assure that the field conditions can be simulated in the laboratory. It is only a simulation, but there is something missing. So what we done is, let us have an accelerated pavement testing facility. So with that idea at NIT Warangal, this is what these small accelerated circular test track we have constructed. So what we have done is, this is in our non-woven coir mat has been embedded, and see the anchorage that we have done it. And these are the different forms during the work. This is the student who has done the work, and end of the day, this is what how they are making these things, and this is what after making this, it will once we have designed a calculation. What design calculation means? Low volume roads are designed for 10 years. Let us say T4 traffic. Okay, so we had some calculations. Making this calculation, how many revolutions for 10 years? 2 lakhs, 3 lakhs, 4 lakhs, 5 lakhs, or 10 lakhs. So we have done according to the calculations. We make those calculations, data has been obtained, and we got a very, very, very huge quantity of the data. Once that is got, and this is the different operations and the process in the preparation of the subgrade, compaction of the subgrade. This is what the strain gauges or LVDTs that we are embedded into the system, into the ground, and this is what the system designed by us. And you can see different load gauge sensor that has been given. And end of the day, you can feel the test track. You can see the test track. So on the prepared subbase, after this is what the erupting that we could observe. So what we have done is, we got an enormous data. So this is what we have done in the laboratory, as I told you. Different combinations, BC soil subgrade and without coir mat. Observed at depth of 11 mm, this many cycles. One combination, two combination, three combination, this is the layer, and you can see this is what the NF, that is the number of repetitions the pavement is going to failure at the design life. So end of the day, what we have tried is, I'm simply showing a glimpses of the analysis. You can see here, we are interested about the rut depth. What is the rutting potential of the coir geotextiles over this material, of different materials. You can see here, without reinforcement with woven, reinforcement non-woven, coir mat, and the reinforcement with a geogrid plus non-woven coir geotextiles. So we use a separation as well as a reinforcement function. So you can see here, without reinforcement of coir geotextile, rutting was around 35, and as I shown in the laboratory, we got around 30, and the field is 35. And here you can see the reduction is almost was a 10 for the different criterias. And this is what the comparison has made by student. Conventional flexible pavement without geotextiles of 480 mm, there is no reduction. Adapted thickness with the woven coir mats is 350, saving in this much. This coir composite, this much thing, this much saving. Adapted thickness for a combination of this is the meeting, this is the reduction in the thickness. Okay, so this is what the study that we have conducted, that we carried out at NIT Warangal in order to, and we have also recommended, while scrutinizing a few DPRs, we have also recommended a few of this technology to be adopted in the state of Andhra Pradesh, in the state of Telangana, where engineers are worried about the Sir, who will design? What is the designs? We are doing the design, and we are requesting them, sir, please give us an opportunity to construct the test track, so that we will come at the end of the day, we will evaluate it and we'll share the results, and we can definitely we will move further. So to summarize my presentations, so we are discussing about the assessment of suitability of the selection of the geosynthetics, and what are the wide ranges of solution of the LVRs. So geosynthetics can facilitate the construction and very cost effective. Many simplifying soil chlorination available as on today. And what I feel is, in India especially, geosynthetics are generally underutilized on the low volume roads. We need to accelerate this material, and we need to see the life. We can achieve the long lasting or lifelong rural roads of payments. So thank you very much. Thank you for your kind attentions. So as I told